Hello, I'm Jacob Briggs, and I am here to look at my linked list to do the video talking about what it does, all the different things. So first of all, we make the node and we give it a spot for a number to hold, and then a spot to hold the previous and the next nodes in it. And then here we set the default values of head and current, which we'll use to make our way through to look through it all to null so that they don't equal anything at the very beginning. And then at the beginning we have insert and we'll insert a number for this. And so first off we create a new node. Um, Wait, I think first we're actually supposed to talk about what linked lists do. Let me pull that up really quick. Um, mm, 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 mm. Okay. Okay, just the code. Okay. Okay. So back to what I was talking about. We make the new node so that it doesn't store it on another one. It's its own new thing. Um, and we check to see um, if if the head is null, and if it is, then it sets our head reference as the first one. And this will only run for the very first number we input, because after this head will not equal null, and what it does is it sets our head to this new node that we created, and it also sets our current to this new node. Um, and then our general code that runs every time, we have new node, the number of the new node equals the number that we put in our insert function. Um, and then since there is nothing next for right now, we set that one to null. Um, and then um, we set our previous for the new node that we're creating to the current. So what that would mean is, since we haven't stored anything new in current yet, that current would be, when you put a second number in, current would still be the first one right now. So what that means is that when we put in, like, say we add in 1 and then 2, 1 would be our current still, and then we would be setting the new node to 2, but still setting the previous connection to 1, since we haven't reset what current is. And then the next line, we make the current, so like say 1, the next is equal to the new node that we're creating, so the ones next would then become 2, so that they would be connected like that. And then our current then after that becomes what our new node is, so that we can, so the next time over we can like reset that. And then display is just a simple while loop that looks for as long as we have them, and then it just puts out the number. Um, and so for the find, what I did is I did something very similar to the display, and what I did was check to see if it's a Boolean first of all, so it tries to find if it's true or false. Um, and what it does is that it goes through each thing in our linked list, and if the current one that we're on's number equals our number defined that we input, it will see out that that number was found and return true. And if it doesn't find that, then it just moves on to the next one. Um, and then if it doesn't find it at all after it gets to the while loop, it will return that this number does not exist and return a false. And then our delete function, I'll show that all of this works because I have it all like set up to run one after another. And so our delete, we have some examples that I looked at, made sure that we covered um, different sorts of parameters. So if we were to be deleting the head, we would make sure that the one after the head becomes the new head. Um, and then this one checks to see if the spot we're deleting isn't the last one, so that we can fix those connections. Because what this does, um, this is the delete was a little really confusing. I had to look at a bunch of different examples to kind of get this. And I still I still don't fully uh I can't fully like explain it. Like I understand, but I'll see if I can put it into words and explain it in my own way. So our node to delete is whatever number we want to find. And our its next. This is just really confusing. So the next one's previous should now equal this one's previous. So it's it's really weird and confusing to think that like the next previous is now equal to just the previous. Um, it's these two parameters are more so that when you're deleting it, um, because if you were to just delete it without doing this, then it wouldn't connect those back. So say if we had like 1, 2, 3, 4, and we deleted the 3, if we just went through and found it and deleted it, then the 2 and the 4 would not be connected to each other anymore, forward or backwards. So what this does is it goes in and it checks, hey, is this one the last one? Or for next, is it the last one? And for um, previous, if it's the first one. If it isn't, if it's like in the middle of the list, let's go through and make sure that when we delete that one, it sets it to the next one down or forward so that they're still connected, um, instead of losing that connection after it's deleted. And then our delete, and then it's just a delete that node, um, and then return. And then so in our main, we insert 1, 2, 3, 4, and 5, and then we display those numbers, and we pause it to check if we display all of those. Actually, I can go through this. I already built it, so let me start without debugging. And so what it does is it says displaying nodes now, and it displays 1, 2, 3, 4, 5. And then what it's going to do next is it's going to try and find the number 4 and then try to find the number 6, and then pause to see if we were able to find the numbers. So let's continue. Trying to find a node with the number 4 now, and then it says that 4 was found. And then trying to find a node with the number 6 now. 6 does not exist because we only put in 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5, no 6. And then what we do next is we're going to go in and we're going to delete heads next, which would be number 4. And what we're going to do is we're going to delete that, and then we're going to display the new nodes so you can see that 4 is gone, and then we'll also try and find 4 again to see if it is actually gone. And then we'll pause it again. So let's continue that. Deleting the node with 4 now, displaying new nodes now, 1, 2, 3, 5. Checking if 4 can still be found. 4 does not exist. And that is my program. I was not able to work on the extra credit. Hopefully next time, if there is extra credit on the next one, I can get that done. Hopefully I won't miss 2 sessions in a row and have to lose time watching through the sessions again later. But thank you so much. I've been Jacob Riggs. Goodbye.